hear me. I am Eleanor, as Lee said. I work for CU Boulder's Cooperative Institute for Research in Environmental Sciences, supporting the National Integrated Drought Information System, which is a mouthful. But at NIDIS, I support communications for drought information. And so if you've ever received an email from NIDIS about webinars or our Dry Times newsletter, that most likely came from me. I'm going to speak a little bit today about the value of communicating soil moisture science. I want to be a little more mobile. So I'm going to talk a little bit about the value of communicating soil moisture science, and then we're going to work through an interactive exercise to develop a message around something that you're working on. So just, I know you've seen this slide already, so I'm not going to stick on this for too long, but I know we have a couple of newcomers to the National Soil Moisture Workshop, including me. I'm a first timer and very happy to be here in Fort Collins. But just to tell you a little bit about NIDIS, we're one of the co-hosts of this workshop alongside the USDA ARS, and we work to develop, coordinate drought monitoring, forecasting, planning, and information across all levels of government in the United States. And the mechanism that we do that with is via these regional drought early warning systems, or DEWs. So as you can see, we have 8 DEWs regions in the continental United States. These are the coordinators who are responsible for each of these regions. So if you're within one of these DEWs, please come talk to me or Elise afterwards. I know a number of folks in this room are also very familiar with NIDIS, so you might even be able to ask her at your table. And how we support the National Coordinated Soil Moisture Monitoring Network, and drought early warning across the nation. And then just to kind of tell you a little bit about me. So I graduated with an undergraduate degree in science and agricultural journalism. And I immediately took a job as a journalist in Western Colorado, which is where this first photo is from. I was covering a wildfire, and we had gotten to the site, gotten to the parking lot where we were meeting all the Forest Service folks, and they handed us like a dossier. And it was stapled together, and I cut my finger on the staple, and you can't get injured on a fire site and not get care. So the firefighters made me go to EMS and get a Band-Aid, even though I tried to refuse it, and they would not allow it. And the reason I mention that is because that was really my introduction to water and soil hydrology and fire science and all of these fields that are affiliated and are next to soil moisture. From there, I got really interested in Western water management in particular, and I went to work for a water district in Western Colorado. And then I pursued a master's in water resources at the University of New Mexico, which is where this middle photo is from. And so that is not me. I'm behind the lens. As you can imagine, as a journalist, and you've seen me taking photos around this workshop, I end up behind the camera more often than in front. But there we were doing some soil permeability testing, which ended up just being a class project. It's not published anywhere. But that was looking at different soil types in Rio Rancho, New Mexico, to understand how flash floods would move through the soil in those ecosystems for the purposes of planning for development, because it's a community where only 1/3 of the community that they plan to eventually grow into is currently built out. And so then this last photo is a photo of me. And this is a pop quiz question for those of you in the room. Does anybody know where this stream gauge is? And I'm going to put the USGS table on the spot. It is not Cameo, it's in New Mexico. It is the first one. It's the first stream gauge in what became the USGS stream gauge network at Embudo on the Rio Grande in north central New Mexico, centralish New Mexico. And I threw that in there just to prove that I can sit at the cool kids table, that I understand your science and I understand how important it is. We talked a lot this morning about how critical soil moisture is to flood forecasting, drought forecasting, fire forecasting, landslide forecasting. All of these life-saving, can be life-saving sciences and forecasts. And so I also understand how complex it is to communicate this science, because I realize, I mean, you're running on complex models. You have to explain the differences between the different models, the differences between the different measurements and the different soil layers. And then within that, there's however many equations within each of those, buckets that you also might want to explain. And so that begs the question, what is the value of communicating soil moisture science? And this isn't a rhetorical question. This is a genuine question for the room. And I'm hoping a couple people might be willing to share a moment that they've communicated their soil moisture science and what benefit, or maybe you saw some negative outcomes from a communication. But I'm wondering if somebody can answer what value they've seen in communicating their soil moisture science. And I have prompts if I need to prompt you.
So in my previous position, I worked quite a bit with the local community around water and water supply issues. And so getting them familiar with the idea that soil moisture was related to the snowpack to runoff relationship was something I put a lot of effort into. And on one occasion, it had the direct consequence of someone recognizing that that was information they wanted and recommending me somewhere else where our organization was able to get a grant to support that work. So it was this is maybe not a community value, but it all comes back around because that work then fed back into community needs. Circular example.
Well, I've heard some others this morning, so I'll call them out if I need to, but I'll stand here in silence for a few seconds.
I think a good one would be to explain your friends and family of what is it that we actually do.
Yes. Well, and then let me ask you too, though, to add, what is the value in your friends and family understanding what you do?
Right, respect.
Yes. Yes, that was one of the ones that I was going to try to prompt out of you. So of course, funding it's necessary to support your research. One of the other things that I'd mentioned too is inspiring new scientists. I think we're not going to build the community if we're not talking about it. And while I was in my master's program, I actually had a professor who said that groundwater science is stagnant. It's dead. There's nothing more until we learn how to better model groundwater. It's not going anywhere, and there is no better modeling to be had. And imagine receiving that as somebody who's interested in groundwater science. So the way that you talk about your work, the way that you talk about your field is also important to inspiring more people to join it, both people who are mid-career and, kind of a lateral move from an adjacent field into our field, or just new scientists. I don't really want to totally out people, but who here is under 30? Okay, so we need more of us. And to have more early career scientists, we need more people drumming up interest in our science. So I also think that communicating your soil moisture science is an investment in the future of the field. And you've had a few minutes to ponder, so I'm going to see if anybody else wants to discuss one of the benefits or some of the value they've seen in communicating their science. Okay, oh, yes, sorry, so sorry, Roddy, go ahead.
On one of the products you created to make it better.
Okay, and so in case the microphone didn't pick that up, Ronnie Leeper just mentioned getting feedback on some of the products that you created and being able to iterate upon those. And then the other one that I wanted to hit on was just, has anybody here had to justify their work to a governing body, like the legislature or board of directors? Raise your hand if you've had to. Or if you've had to informally justify your work. So that's another huge, if decision makers don't understand what we're doing, how do you expect them to continue funding your work? How do you expect them to continue funding development of new products? And I think in the current atmosphere that we're in, that's really critical. So those are a few of the reasons we, as a collective and from my notes, those are some of the values that I brainstormed about communicating your soil moisture. But certainly there are more than that. And I encourage you to ponder that earlier on when you're starting a new project. Think about the end game. Think about what you're delivering to the public or the state or the county. And then think about too, how are you adding value and making sure that they of this, I want you now to think about a project or, it can be research, it can be, a publication that you've, recently created, this liberal interpretation of study and research and project. I'm probably gonna use the word project, but interpret that as you need to. So think about a project that you'd like to communicate out right now, and I'm gonna take a pause so you can really ponder. Hopefully everybody has their project in mind. Now I'm going to talk to you a little bit about some of the best practices to communicate your science. I think iterated on this idea that science isn't finished until it's communicated. It's a cycle. We've talked about the feedback, about getting feedback from users and incorporating that into your work. If you even think about the process of publication, the traditional scientific method and going from research to develop, research proposal to research completion to publication, that's a cycle of communication as well, because you have communication to get the funding, you have communication to coordinate, graduate students and different partners within different universities or your university or within your agency. There's communication, there's cycles of communication throughout the scientific method, and the scientific method itself is one big circle that starts and ends with communication, from funding proposal to publishing your results and hopefully communicating those results out to the public beyond just a journal article. Because as we mentioned earlier today, the public and decision makers aren't often reading journal articles. So if that's the only way you're communicating your science, you're probably not reaching some of the audiences that you really want to reach, given the things that our community needs. So the first step in thinking that in my way of thinking, which this is entirely just the way that I approach science communication, I'm not endorsing this as the best way. This is just the way that works for me. So I always start off with identifying your audience. You can replace audience with stakeholders or partners or whatever group that you're seeking to communicate with. Obviously, that's your audience. So in this example, imagine there's a party tonight, and I'm a big fan of chocolate chip cookies. That's my favorite cookie, if you want to buy the way to my heart. So I want to make cookies for this party. I want to make sure that we have cookies at the party. I'm not going to try to get the public on board with that as an entirety, because that's way too broad. The entire world can't come to a single party. And so often, I mean, especially in my work where we're doing drought information for the nation, we have a nationwide audience. And so our audience is the public, but you can't just say my audience is the public because it's too broad. So the way to get around that whenever you do have a really broad general message is to kind of caveat that it's the public in Illinois, or it's the public who is interested in watering their lawn and wants to understand smart irrigation practices for lawn watering. So you just want to narrow the scope of that audience in some way if you're thinking about the public. If we are thinking more specifically, then you do successfully narrow that scope, you might think about some of these other questions, like how much does your audience know about the topic? How is this information going to impact them? What do you want them to do with that information? And how are they going to react to it whenever you present it to them? So if I tell my group of dentist friends that we should bring cookies to the party, there might be a little bit of hesitancy, like they're too sweet, they're too sugary, like I don't want cavities, I don't want my patients to get cavities. All the people at this party are my patients, and it's going to create more work for me, which maybe there's a kind of a inverse intention there. But the message of we should bring cookies to the party is going to be different for dentists compared to somebody like the Cookie Monster, which this is a government available licensed Cookie Monster, because Sesame Street, I didn't know until I prepared this presentation, like the Cookie Monster is not in public domain yet. But the Cookie Monster, I mean, he's going to want more cookies. He has cookies, he wants more cookies, wants more tools to develop more cookies. So whenever you say, like, let's bring cookies to the party, the Cookie Monster is obviously going to be on board. Maybe the Cookie Monster is going to help you find funding to get ingredients. Maybe the Cookie Monster is like gonna use the cookies to make a cookie castle and use your data or tools to do something else really cool. So obviously they're going to react in a much different way than dentists, and they're likely going to be more on board. So you can think about how your invitation to bring cookies is going to change to them. And then finally, we have Grandma, and let's call her Little Lucy. Grandma and Little Lucy know a lot about cookies. They know all about it. They're probably already making them. They clearly already have the ingredients. They have the tools ready to make the decisions to make the cookies themselves. So whenever you present to them too, obviously your message is gonna have to change from like, let's go buy ingredients, to, like, please, grandma, please, this is a worthy investment of your time. And once we're on the other side, we'll all enjoy cookies. And so that drives me my point about audiences and the broad scale of audiences. And then the other thing too, I think with audience, especially in communicating science, people kind of worry about the idea of dumbing down your science for a public audience. And what I would recommend to you is don't think about your audience as dumb or stupid. They're very smart people. Whenever you think about the public, I think you can replace the kind of nebulous gray public in your mind with somebody who assume that they're well-educated, assume that they're gonna understand what you're saying, but they're not in your field. So imagine it, for example, I know there yesterday, or maybe even today too, there's an equine workshop at CSU's campus. So whenever you talk to a horse veterinarian, you're not gonna assume that they're dumb. They're obviously not gonna understand like field capacity without additional context. So whenever you are communicating to a general public audience or a general public in Illinois audience, think about it as explaining it to somebody who's very well, they're adapted to receive information, they're well educated, but they just aren't familiar with your field. So whenever you need to replace somebody in your mind, think of your other scientist friends who aren't in this field. So then whenever it comes to actually developing your message, that the way that I like to build out how I'm gonna actually write, so I'm a writer primarily. I do some other forms of communications, but that's where I feel most comfortable. And whenever I'm thinking about how I'm gonna write a story, this is what I come back to, and this is the inverted pyramid. It's a pretty old journalistic format. And if you notice in a breaking news story, most breaking news stories still follow this format. And the idea is sort of like a reverse food pyramid where, food pyramid, the traditional food pyramid, which I realize is not USDA approved anymore, but you had the breads and then the sweets are at the very top, and this is where you spend the most time. It's kind of the reverse of that, where you want to spend the very, very top part of your story or of your message should be focused on the who, what, when, where, how, and what the details that a reader has to know, because your reader doesn't have a long attention span. So if they're going to read one thing, you want them to remember that one thing. So this is really developed with the idea that somebody's not going to make it to the bottom of the page, but you still want them to take away your message. So how do you format it and think about it in that way? So first up, the most important key takeaways. Second up is going to be important context, and things that are important to understand that first top key takeaway, but aren't so critical that you're going to absolutely miss the message if like you're still going to be able to walk away from the story and understand what's going on without it. And then finally at the end are things like, where do you go for more information? If you are we have, one of the things that we struggle with in NIDIS is that we have a really expert audience, but we are trying to reach the people who just water their lawns. And so how do you connect with both of those people? You give them tools to get to the next step, to get to the next information. So at the end there, I always like to link to learn more about this. Here's the study, blah, 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 blah. Here's the extra details that maybe the general public might not be interested in. But for an audience like you, I want to make sure you're connected to the resources. So the other thing to keep in mind is that you can create gateways to information within your message to keep it at a higher level for a non-technical audience. So then this is how I propose that you can move from kind of the journalistic framing of the inverted triangle to a scientific communications, how to format scientific communications in this way. So first up, this is a lot different from kind of traditional scientific communications where you've got almost every single paper is abstract, introduction, methods, discussion, conclusion, or conclusion discussion. And I know some journals are moving away from that, but of course that's the standard. And this is a lot different way to think about things because you're often leading with conclusions. The most impactful thing is often what your research result is or what its impact to society is. Not necessarily that you used this probe and it was at this depth and you had 3 rain events during this week. Those details aren't going to drive home the message of the importance of your work. And so while they're important to include, you want to include them later on. So whenever you get to the second layer here, these are the things that people need to know to understand your research and to understand why those conclusions are important to society. So you might want to mention, this was a big multi-agency effort, across these different universities. This university funded this research, or NSF funded this research. We used soil moisture probes. You might not want to get into the like nitty gritty details of your methods, but you can mention them here if it's important to understand the context of the study and why it adds new information to society. And then finally, in the conclusion, that's the details that are, if you're gonna yell something from the rooftops, you're not gonna yell these things, but they are important to understand to support kind of the taller levels of that pyramid. So that's things like caveats, like why this model might not work for these applications. The really detailed descriptions of like the different levels of soil moisture monitors that you used and why you chose those. Those are things that are more interesting to the technical audience, can go at the very end, or again, you can kind of link to them elsewhere to create gateways to more information whenever you're trying to reach a non-technical audience. And so then just to iterate, kind of what this looks like with an actual study. This was a story that we did, and I chose this just because this was the most recent soil moisture story on drought.gov, which is that's where my writings end up. Elise actually wrote this one, and this was about Missouri's build out of their soil moisture network, which they're in the house, I believe, today. So if you have questions about the project, can the Missouri folks raise their hands? Okay, there's Amanda, if you have questions about this network. And this is the QR code goes to this story as well. So the big key takeaway here and if you want to imagine developing this, like imagine standing on top of the skyscraper with a megaphone and you get 2 sentences, no more, to really sell the public on what your research is doing for them. So here, that key takeaway is that Missouri is leveraging partnerships to boost soil moisture data for early drought and flood warnings. When you move into the context, it's important to understand why this is important. It was because that was developed in response to significant flooding in the Midwest. Several states identified this as a need. The gap that this research addresses is the need for different sensors and different soil types across the landscape in this state. And then we also broadened it out because this was like I said, on drought.gov, we're the National Integrated Drought Information System. We also needed to discuss the importance of soil moisture networks broadly and how statewide networks, why it's important to fill the gaps in statewide networks. So that was the context that supports that main point. And then after that, we discussed things like some of the like sub networks that it overlapped with and some of the data that it pulled in. The planning documents that identified the need for this network, the really specific funding sources for this research and for these stations. And then again, some of those learn more links. So a technical audience can go somewhere else to get more information that's not appropriate for a story for the general public. And our audience, we always say our audience, whenever I say general public, for NIDIS, we define our general public as concerned citizens who are interested in, we call them lawn waterers. So they're people who are engaged because they want to use the information to understand their, home level or garden level, soil moisture and drought information. And so like I said, this is not the best way to develop a message. This is just, I come from journalism. This is what was drilled into me whenever I was in school. So this is the framework that I lean into the most because it's the most comfortable for me, just as I'm sure you have models that are more familiar and comfortable for you. Same thing here. So what I encourage you to do is to find a way to develop a message that works for you. If this doesn't jive with how you think, find one that does so that you can kind of build the reflex of developing this skill and of thinking through how you're going to strategically communicate this to the public. But one thing I do like about this format is that it can be applied to many different communications. So this is an example. This was, like I said, I tried to summarize the story. This is what that could look like as a tweet. Headline first, then this more details. The soils act as a reservoir for water storage. The soil moisture data can illuminate how water moves through a landscape. And then learn more, go to drought.gov and you can see the entire story. And then again, that entire story links to other resources. And then finally, this is kind of not fair to the idea of visual communications because that is a whole talk in and of itself. So I put a couple QR codes here of some resources that I like. about photography and taking better photos to accompany your work, and specifically field photography and approaches to document your field work. And then this one on the far left is Nature, the journal Nature's best practices for scientific graphics, and it's got a whole list of resources that are really great. And so again, just to drive home, your visuals are part of your key takeaway. So if you're trying to decide between several different visuals, think about the message you want them to take home. Do you need to present temperature and precipitation and evapotranspiration, or can you just use evapotranspiration? Like, does that drive home the point as well or better than some of the other things? So keep it simple, both in terms of what your individual graphics are showing, but also in terms of the number of graphics that you're showing. And then the other thing is just take more photos. There's a quote, and I'm not going to remember who said it, but they were at the very top of Everest, and they were worried because the only camera that they had to take a photo was their iPhone. But the camera that you have is better than no camera at all. So don't let your equipment stop you from taking photos, and don't let your skills stop you from taking photos, because the way that you get better at developing messages, at communicating your science, at representing your science visually is by practicing. So you have to take a lot of bad photos to get a few good ones. And that's true even whenever you're a professional photographer. And then finally, people like to see people. So when you can, take photos of people. And I realize our work is often in the dirt, literally. It's often dealing with microbes and teeny tiny rocks and things like that. But people, you can have hands in the photo, and people connect with people. And so just do your best to try to get some images of people actually working on your research. And with that, I want to move into our activity. So at these first two tables, I'm gonna again lean on my new USGS friends. If you can pass out, start circling those flyers in the middle of the table. They're gonna move their way from back to front. And this is essentially, the image on the screen is the same image, the same handout that's coming to you. I just wanted to be able to make sure that the people online, if they wanted to participate, could participate. So this is working through those steps. The only one that's missing is thinking about a visual, which I would encourage you to do. And what I would like for you to do is to take a few moments, that project that you thought about earlier that you'd like to communicate better on, apply this presentation to that project in your mind. So think about your audience, think about how they're going to respond to your message. And then you're going to find somebody next to you and find a friend, present that message to them, and hopefully you'll be able to kind of give them the audience that you plan to talk to. So maybe they can wear that hat and give you some feedback on, like, how well will that message resonate with that audience? How are they likely to receive it? Do you think that they're going to receive it the way that you intended them to receive it? And this is particularly helpful if you're sitting next to somebody who's not so familiar with your work. Is it understandable? So that's where that's the interactive element of our presentation. And I'm going to leave you to that to develop your messages. But I also am available for questions, and I don't know if they want to do questions as a group, or if just individually, if you want to connect with me. I'm happy to talk about reaching audiences, strategizing for media interviews, if you have a specific communications challenge, come find me. And I will be on the field trip A tomorrow too. So if you'd rather talk in the forest, I will be around and available to do that.